Hey, it's Kristen. I'm looking at these questions and wanted to practice my video skills, so because I need to start doing that in the fall, or actually this summer for my classes. So I thought I'd give you a little video. It's just the questions you already have, but I thought we'd look at them. So for any point x, y on the graph, we remember that x is our is our left and right. Excuse me, left or right and left. Say what I'm writing. So again, x is the left and right, and y is the up and down. So I could even say that. I could go ahead and label that this is my x and this is my y. And then it says if y represents the number of meters, so we've got 1,000, 2,000, we're all talking about meters here. I've already kind of written it. I thought about this before. What could x represent? And the equivalent measurements over here. So what would be an equivalent measurement to something compared to meters? So that's what we're doing, is comparing. We're saying that one something equals 1,000 meters. So we could say that in an ordered pair. We could say 1 is the x, and we don't know what it is, equals 1,000 meters. We know the number of it, but we don't know, they don't know. They're asking us to guess on what 1,000 meters is in this relationship, and what is 2,000 meters in relation to 2. And so this basically says it's equivalent. They meet. So you're saying 1 is equivalent to 1,000. So 1 something is equivalent to 1,000 meters, and that's something that we're going to have in our head for this test. So might want to go back over the metric system to make sure you've got all those conversions. Maybe you do, because you've been teaching this stuff more recently than I have. At least the sense of convergence. But, you know, I let my students use their resources, so I have conversion tables and all that stuff available to them, because nobody keeps, I mean, some people keep this stuff in our heads. We keep the inches and feet in our heads, but when it comes to these meters, nobody really keeps that in their head. So we all have Google at our fingertips. So anyways, definitely want to refresh your memory on that before you go take that test. But again, and that's just simply knowing that 1,000 meters is equivalent to 1 kilometer. So you choose A. And then the bottom half, this is one we've already looked at. We're trying to see what is the equation of this line. And so let me kind of zoom it in a little bit. I've got that line, and I've got these equations over here. And remember that you can pick out the information either from the graph. In fact, because they were giving us this graph, we need to pick out all our information before we even come over here and start checking on these. So remember that we can go over here and find our y-intercept. I'm trying to scoot this up so you can still see it. I think I'm going to do this better with better light. It seems a little dull in here and dark. So if I go, let me see if I can zoom in just with my phone. Nope. Me and the phone are not working. So if you think about that, we're looking at this right here as our y-intercept. And so I can put a little dot there and tell us that. Remember, I was telling you before you left the last time we were together, the main things it looks like that you're going to really need to remember is y equals mx plus b, and what the y, the m, and b represent. We know what y and x represents. It's the x here is the horizontal axis, and the y is the y-axis. But that's really not what we're dealing with right here. We're dealing with the m and b of that. So if we think about y equals mx plus b, m is your, remember, slope. And we haven't found that yet. But we did just find our b. We found that our b is right here at 4, positive 4, because we went up. Remember, everything starts from the origin, and we went up to 4 on the y-axis. So your b is 4, or in the sense of a point, we would say 0, 4. Because remember, we don't go, remember the x and y in an ordered pair gives us our directions of how to find a point. And so we use the origin, we say we're not, for this point right here, we use the origin and say we're not going left and right. That's what 0 tells us. There's no direction left and right, we go up 4. So then we come over here and we can go ahead and put that piece in. We're getting close, and in fact, that could probably help us narrow down a little bit, except it doesn't. Oh, they're so fun. Okay, so notice that we don't see anything over here with a 4 in the B spot. As we can see, That's -3, -12, 3. All those are our B spots, and there's not a 4. So that means that we've got to think through a little bit more. So don't jump ship yet and think we've done something wrong. It's just going to have to keep thinking. It looks like it's not going to be an easy one. So that just pops right into the y equals mx plus b. That would be really awesome if we come over here and found a 4, like we have in one of our other questions. So then I'm going to come back to my graph to find the slope. And so notice that going from that first point, remember that whatever the intercept is always our first point. Going from that one to the next point, I'm just going to travel down until I know I go through another gridlock. One that is an absolute. Because I could come down here, I could come down here, but those look like they're fractional answers. I mean, we could maybe, no, neither one of those. I want it to be a solid, definitely right through a point. And so this point right here is a point. Either I can identify that point, like label it, say I went to the right 2 and came down -2, and now I've got 2 points. I can then use, remember my slope formula. So we've got 2 different options here. We can remember our slope formula and just calculate the range, the change in y over the change in x, which would be, remember the slope formula here is y2 minus y1 over x2 minus x1, and I highly encourage, so there's the formula, sorry. I'm trying to do this, it's not really working out. I'm trying to do that. I want to match the stuff from the formula on my points. I want to label my points. I highly encourage my students to do that. So, and it doesn't matter which one you label as your 1 and your 2. This is my first point. So its subscript will be 1. So because I'm deciding that that's my first point, x1, y1, and this is my second point, I'm going to call it x2, y2. And you can use the slope formula to find that. So we would use -2 minus 4, goodness. So again, -2 minus 4 because of that formula over 2 minus 0. And so then we get -6 over 2, and we get that -3. So now we have, so we found that, again, -3 was our slope by calculations. And then we can say that now. We can say, actually, that m is -3. So we can come over, oops, are you able to see me? Yeah. Come over here and plug it in, because remember, m is your slope. And so we're here. So, look at that. That's the true y equals mx plus b slope-intercept equation. I should be done, except that I come over here, and I'm not. So, we need to think through, I mean, since that is my equation and none of these are an option, none of the ones that are straight y equals mx plus b, b through d are not matching, I'm going to have to go up here and think about a. Go, well, how could I change a? How could I change my equation to look like a? And let me write it over here so we can see it a little better. So again, y equals -3x plus 4. If you look at it, if you think about each term is a multiple of 3. So if you think about how we worked through some of those y equals mx plus b equations of isolating that y, one of our steps was to divide off what was in front of y as our last step. We don't have anything now, but that one does. And if I multiplied through by 3, because that's what we did to undo it to get it to that point, in those other examples, if I multiplied 3 by 3, notice if I multiplied, we get that one of those answers. We get that answer. And this was kind of a mean question. It really makes me not happy that they did that, but that is our answer, A. So it's a lot of talk on slope here, slope and y-intercept, just because I really think that's one of the areas you struggle. And now you have a video about it. Going back to, did I zoom in? I did. Okay, sorry. Going back to slope, where we use the formula, and let's say, oh my gosh, I've forgotten the formula. So let's go back and think about how we can find the slope from one point to the next with just directions. Because remember that slope is, and that remember y's over x's, rise over run. So we'll say that, y's over x's, rise over run. Think about run is going this way, rise is this way. So that'll help, that triggers my memory to remember that the y's are on top. And so that means that getting from this point to the next, I need to go directionally up or down first. And to get to that point, I go down. And so as I travel down how many spots? That's a 2. So let's pull that back up in here. That's a 2 and a 0. So we went 2, 4, 6, right? As we traveled down 6 spots. So we went down, to indicate down, we use a negative, and we went over 2 spots to get to that point. So +2. And so then you can just kind of pop it right there and say -6 over 2 gave us that -3. So it's just a different way to look at slope when you're just looking at the directions of it. So if I'd written all this out and given it to you, you might remember some of it, and that's what I'm struggling with my students, is that I can give them this stuff all day long, but it's me speaking it that we all, obviously, speaking it and seeing as I write it what I'm talking about, because all that kind of looks like mumbo jumbo, but as I walk through it, hopefully it helped. So I'm going to try to send this to you. I'm going to try to put it on YouTube or something. Again, I'm really just trying to get my videos aligned for this summer. Notice we only went over 2 questions. I'm going to have to crank that down and get a little bit more efficient with it. Anyways, okay. I will see you this afternoon.